Okay, so today's lesson in 3.1D.2, it's the second part of composing functions, and today's topic is composing and decomposing functions. But we won't be using algebra for composing today. We will use algebra, however, to decompose. So your objective, you will be successful when you can evaluate compositions, given tables and graphs, and you can decompose a function using algebra. Okay, so let's take a look and remember what compositions mean. When we're working with composite functions, that means we're inputting one function into another function. That's what it means when we're composing. So composing, just as a reminder, means plugging one function into another. So just a reminder about that. We're not multiplying, we're not adding, we're not subtracting, we're not dividing, we're composing. So we're inserting one thing into another thing. And then we'll use some math, of course, and some operations to simplify. Okay, so here we have several values of two functions, f and g, are listed on the table below. So I'll go ahead and do my work with f in red. So there's my function of f right there. There's my inputs of f of x, and there's my outputs, my x and my y. And this table has my function g with all of my inputs and all of my outputs. Okay, and here's what I'd like to do over here. I'd like to label my x's as my input and my y's as my output, because that's typically what we do when we're solving a function. We'll input something for x, we'll do a little magic math, and then we'll get an output for y, or f of x. F of x means y, or g of x means y. Okay, so remember that we are composing. So this says we're going to plug in our g of 2 into our f function. We're going to get an output. Remember, anytime we go equals like that, this equals an output. Fine, don't write that down. I'm just saying something to you, so pay attention. Remember, this equals y. Remember that? The whole thing put together equals y. When you see this, f of x equals y, they mean the same thing, right? So remember, your final thing after you do all your composing is an output. So I'm going to give you a little bit of instruction here. These are regular functions. They're not function inverses. We don't see things like this, so we don't have to worry about switching our outputs and our inputs or anything. We're going to follow this process. We are going to input, output, which is going to turn into an input, which is then going to give us another output. So input, output, input, output. Got it? And the first time I do this, I'm going to do it with like a function machine. Well, we'll plug a number into a function, and we'll see what the function does and get an output. Then we'll take that output and plug it in. So first time I'm going to do this with a function machine, and then I'll move away from the function machine and just work on my method, which I think is a little faster. So this says we're doing the f of g of 2. So we're plugging the g of 2 into f. So that means we're going to take 2. Sorry, that's G. G is 2. Remember, we're doing blue, so I'm going to change colors. So I'm taking 2, and I'm plugging it into G. So this is an input. I'm taking 2, and I'm plugging it into G. And it's going to produce an output. So what's coming out if I plug in a 2? Look at my G function. What's my g of 2? It is 1. So I plugged in a 2 into my g. I got out a 1, according to this information here on my input-output table. Now, what I'm going to do is I'm going to plug 1 I'm going to plug 1 into f. So I did 2 in equals 1 out. And 1 in, so I'm going to go plug 1 into my f. So that's right here. What's my output? 3. All right, so here's what we know. The f of g of 2 is 3. So that's one way to look at it. It's an input-output idea. And that's what compositions are. You're plugging something in, you're getting something out. All right, so let's do the g of f of 3. I'm going to do it in a different method now, and you can decide which method you like, and then you can stick with whatever you want. So we're going to do the g of, and I'm going to change it to my other notation, my preferred. I want to switch to red, please. Okay, my preferred notation, the g of f of 3. Okay, so here's how I like to do it. So this means, blue pen, the g of, what's the f of 3? The f of 3 is 2. The f of 3, I'm replacing the f of 3 with its response, 2. Right? And then I'm going to go, all right, so the g of 2 is 1. And with my method, what I'm doing is I'm going from my first statement with a double set of parentheses to my second statement with a single set of parentheses to my final statement, which is the solution or the evaluation of the g of f of 3 is 1. Now, I don't mind how you attack this problem. I just want you to be able to do it on your own. So remember, you're getting input, you plug in something, you get something out. You plug that thing in, you get something out. So you guys do the f of 4 on your own. Okay. So did you get for C? The f of 4 was 3, right? Because you plugged in the f of 4. You plugged in 4 for x, you got 1 out. Then you plugged in 1 for x, you got 3 out. And then the g of 1, writing it in its other notation. I went in 1, got out 4, went in 4, got out 2. Did you see what I did there? I went, okay, I put in a 1, I got out of 4. So I come over here to 4, and I put in a 4, and I got out of 2. So that's the pattern. Basically, I guess I could have went like that. Right? Put in, drop in a 1, get out of 4, drop in a 4, get out of 2. Another way to look at it. Questions about that? Okay. Then let's go look at another example. And I'm keeping them pretty basic today. I may give you like 3 or 4 functions later and have you compose 3 or 4 functions with each other and include inverse functions. So we really need to make sure that you can do this. All right. So here we have the f of x and the g of x. And I think I was doing f of x in red, right? So let's look at this. We have a graph here. So let's look at some x's. Here I have x equals 2 or negative 2. What's my output? 1. All right, so there's a set of points. Let's go to x is negative 1. What's my output? Okay, when x is 0, inputting 0, outputting 5. Inputting 1, outputting 4. Inputting 2, outputting 1. So we have a set of values and a bunch of in-between values that we couldn't exactly say what they were. And then over here we have a g of x function, so I'll do that one in blue. So now we're going from graph to table of values and back and forth, but we should be able to manage it. So let's go the f of g of negative 1. So first I'm going to my g of negative 1, and I'm dropping in so the f of 1, right? Because that's what I'm dropping down. And now I'm going over to my f function, and I'm going f of 1 is 4. Exactly. So negative 1 gives me an output of 1, which becomes my new input, and my output is 4. Let's do the next one. So we have the g of f of 4, or the g of f of 2. Color coding here. All right, so I'm going to my f function. I'm inputting a 2. What's my output? If I input a 2, what's my output? 1. All right. So that's the g of 1, which is my new input, and the g of 1 is negative 1. There you go. Okay, so I'm going to finish the video, but I'm sure you guys I'm hoping you guys have got it by now, and if you haven't, I want you to talk to me. So we're doing the f of negative 2. All right, so the f of negative 2 is what? The f of negative 2 is 1. All right. And then the f of 1, so I'm going to go now, x equals 1. What's my output? 4. There it is. Input, output, input, output. All right, g of g of 1. So the g of 1. So I'm going to my g of 1. And what's my output? Negative 1. All right. So negative 1. So g of negative 1. So I'm going to go like this. All right, over here to 1 and drop down. The g of negative 1 is 1. So I dropped in a 1, got out a negative 1, dropped the negative 1 in. Kind of like it on the table like that to be able to just follow that input output. Okay, so there's a little bit of evaluating compositions when you're given values on tables and graphs. Okay. Now I'm going to ask you to do is quite a bit higher on the order of thinking. How difficult, this is a more difficult to do. I expect you to persevere. Some of you may see it like immediately, and some of you may struggle, and it's okay to struggle. Okay. So what we're going to be doing here is we're going to be decomposing a function. To decompose a function, I have to undo what I have been doing. I've been taking two functions and plugging one into another and getting a final function or a brand new function. Now I'm giving you a final function, and I want you to decompose it and tell me what were the two starting functions. So kind of working backwards here. So here we have this set of instructions. It says express y equals the square root of 2x plus 3 minus 4 as a composite function form. So another way that we could look at this is we could say, all right, so instead I could say, all right, so h of x instead of y, I'm going to change it to function notation, is the square root of 2x plus 3 minus 4. And it's a composition. So I could also say the f of g of x is equal to the square root of 2x plus 3 minus 4. So all of these say the same thing. The last one says I performed a composition to get this equation. I want you to tell me what is a possible f of x and what is a possible g of x. Now here's the thing. There are multiple answers to this question. So I will do one, and then I'm going to challenge you to find another pair of functions that will compose to our final function. So here's the function that I propose. F of x is x minus 4. And g of x is the square root of 2x plus 3. So I propose that these could be possible functions that are the decomposition of this final function over here. Now let's check it. Am I right? If I plug this into x, will I get this final statement? I will. So here's what I'd like to see you do. Come up with your own. All right, so there's another option where you put your square root and your f of x. Yeah. All right, so try the next one. This time, let's express it as the g of f of x is equal to the quantity of 2x plus 5 to the 8th. And I'll stop the video so you can come up with one, and then you can check. We'll check back in a sec. Okay, Isaac, you. What'd you come up with for your g of x and f of x? X to the 8th power and 2x plus 5. Sounds good, because the g of 2x plus 5 would be to remove the x to the 8th, or remove the x and insert the 2x plus 5, which would give you exactly what I was looking for. So beautiful. Perfect. Did anybody come up with anything different than that? Joey. So the g of x equals what? 2x plus 5, what? To the 8th power? And f of x equal x? Oh yeah, that would work. You little stinker. That would work. But that's not really decomposing, because you didn't decompose the function. But actually, it's not wrong. What about if I did this? What if I did the g of x equals x squared, and the f of x equaled 2x plus 5 to the 4th? Would that work? Well, let's think about it. If I plug this in here, then that would be 2x plus 5 to the 4th squared. Think that would work? I wonder if that would work. I believe that would work. And so there's a number of ways that you can look at it, but let's just go back quickly here and see how we deconstructed this full-on completed composition into these two. So anytime I see a grouping symbol like a square root or parentheses like this, what I'll do is I will put, for my first function, I will replace what's in my group with x, and I will take what's inside my group and make it my other function. See what I'm saying? I'm going to clear that out. So I think that's probably, I'll just clear it like this really quickly, the most simple way to look at this. So my f of x, I have a grouping symbol, a square root right here. So what I do is I just remove, sorry for the interruption, to repeat. Again, when I'm decomposing, I'm looking at any grouping symbols that I have, and this grouping symbol is my square root. So in my first function, I'll remove what's under the square root and replace it with an x. And then in the g of x, I'll just take what I removed from underneath the square root, and then I have what I need. These two will compose into that final one. So with this one here, my grouping symbol is a parentheses. So I'll remove what's in my parentheses. And that would be my f of x or my g of x or whatever. And in my other function, my g of x, I'll take what was removed from my parentheses. So basically, I'm just going the opposite direction of what I was doing before. Did that help? Yeah. Okay. So there we go. Video's over. Homework you are doing today is on Canvas 3.1D, and we're doing problems 24, and then 27 through 33, and then 28, thank you, 28 through 33, and 37 and 38.